This is a little tutorial to kind of run through the Chapter 20 quiz, the A quiz. I assigned this for homework over the weekend. Actually, I gave it to you in class, kind of as a practice little quiz. And I wanted to run through it. I know that you could probably read through the solutions, but I wanted to kind of just put it out there so that we can have a this little discussion about how I made my choices and got to the end of the questions. So I'm not going to run through the content. I think you can read that for yourself, but on on the question you're proposing, well, they assume that the proportion of Americans that have trouble affording health care is right around 28%. And they have studied 801 black Americans who cannot afford health care. Well, 38, or was it 38% of those said that they could not afford health care. So the question was, is that higher than I expected it to be, or is that just luck that it was that high? And so that's how we're going to investigate this. You're looking at the null hypothesis, which always is represented by using parameters. Never the statistic in this question is the 38%. And so I'm never going to write my null and alternatives based on the statistic. It's always the parameter. So here's where you get p equals 0.28. The alternative is coming from the context. It's asking, is it more severe among black Americans versus just in general? And so we were looking at the more severe. That would be implying a higher number than 28%. So that's why we chose the greater than alternative. The assumptions and conditions here are pretty self-explanatory. It is stated that it's random in the problem. The ability to afford health care is independent from or in between individuals or family members, and so that seems to be good. 10%. Also, if you multiply by 10, you get 8,010. There's definitely more Black Americans than 8,010, so we're definitely less than 10% of the population. When I multiply my success and failure, remember I'm using P0 from the null, not my p hat from my sample. And I multiply those two together. This is p0 and of course q0. You get that from saying 1 minus p0. Both these numbers are definitely greater than or equal to 10. So all this is good, which allows us to use a 1 proportion z-test. When I run that through my calculator, I get out a z-score of approximately 6.29, which is really, really big for a z-score. And I didn't even bother rounding the number. So it's so small. I said the p-value is essentially 0. It's approximately 0. And usually if it gets past like times 10 to the negative 6th or 7th or any more like that, I just typically round that to approximately 0. You're welcome to write down the scientific notation if you wanted to. I would definitely write the number down if it's a times 10 to the negative 4th or smaller. So but this case, it was small enough that we just said, well, that's essentially 0. My conclusion says, so I'm including the 3 elements. I want to refer to my p-value. I want to make a decision whether I reject it or I fail to reject, and then I want to make sure I talk about the healthcare or the context. With a p-value of essentially 0, we can reject the null. This is strong evidence. I use the word strong here because it's a really small p-value. I could have simply said there is evidence to suggest. That really wouldn't have changed my conclusion, but in this case, I was trying to be a little bit more descriptive, and so I used the word strong evidence. But if you didn't, it's not wrong by any stretch of the word. And then put it back in context by saying that the evidence suggests that the proportion of Black Americans who cannot afford health care is greater than 20%. Notice we said it's suggesting this. It's not that it's definitely true. One simple significance test is not enough for me to conclude specifically, conclusively, that this is what's happening. And it may be the case, but I need to bring more evidence to the table and do more studies or things like that before I make that kind of statement. All right, and then the second and third parts were, was it a one-tailed, two-tailed, upper tail, lower tail? In this case, that decision comes directly from the alternative. Since we used a greater than alternative, that's a one-sided tail. The two-sided tail is not equal to. One-sided tails are less than or greater than. In this case, it was a greater than, so above the mean. So that's a one tail, upper tail alternative. The last part was to interpret the p-value. Take some time with this one. Look in the book, see how they word it, look in some of the examples, the odd ones in the back, and see how they kind of rephrase these things. If the portion of black Americans was 28%, essentially I'm saying if the null was true, then we would almost never expect, so I'm saying the p-value is the probability, to see 38% of 801 randomly selected black Americans saying yes to having trouble affording health care. So the probability, if the null is true, then the p-value is the probability that we would see a sample like this one, the way it happened. That's pretty tricky to word sometimes. My recommendation is that you just kind of do a couple of these and see if you can begin to write it out. Even practice writing it out like verbatim from the book, and just kind of get in the habit of how are they wording it, what is the phrasing, what order do they state things in. And sometimes you'll see them write it slightly different each time. And it's not a big deal of how it's specifically worded, it's just that you include those elements, that it's conditional probability, and if then, the if, the null, and then the p-value is the probability of getting a result like you did. If you have any more questions, feel free to email me or ask questions in class.